Now we're going to spend a little bit of time speaking about the test-driven development, TDD for short. Test-driven development, TDD, is the software development process that emphasizes refactoring the code and creating unit tests as part of the main software development cycle. In its purest form, which is not necessarily the best way to go and which is not what we are presenting, TDD encourages creating a test first and then creating implementations for the tested functionality. Here we are showing a modified moderated TDD approach under which the new code is driven by the functionality requirements, not by the tests, and the refactoring and the test creating are the integral part of the main coding cycle. TDD, test-driven development, is a bit of a misnomer for this development method. We believe that the development should always be driven by the requirements, not the tests. But under TDD, the unit tests are developed for all or most of the reusable functionality just as the functionality is being created. Then the test can be added to the automated periodically run collections. Advantages of TDD method. Developers are encouraged to factor out reusable functionality into reusable methods and classes. Unit tests are created together with the functionality and not when the developers have free time. TDD shortcomings. Sometimes too many tests are created even for some trivial code, resulting in too much time spent on test creation and too much computer resources spent on running those tests. TDD, just as any other coding style, should be practiced under the supervision of an experienced architect to emphasize its advantages and to avoid its possible shortcomings. This diagram shows the test-driven development cycle. First, individual developer notices that he needs to create new functionality. He creates the new functionality inline in the place closest to where the new functionality is going to be used. Then he notices that some of the functionality can be made reusable, and he moves the reusable parts of the functionality to a reusable project visible from other projects within the same application, for example, or perhaps even within some different applications. Then he adds tests to cover all the new reusable functionality. We debug and polish the generic functionality, the reusable functionality, while working on the tests. Finally, if we want the tests to run periodically, we add them to the automated test collections to run with some periodicity or perhaps after every build. This is a structure of a project with tests. This is exactly the structure that we are going to be displaying in our Visual Studio sample. The main project is where we assume the new development is taking place. The NP Utilities project is where you put the reusable functionality. It is assumed that this project is generic and visible from many other projects, and NP Utility Tests is the project where you place the tests for testing the reusable. And finally, before we switch over to Visual Studio, the sample solution can be located under this folder under github.com. I built the sample using Visual Studio 2022 and .NET 6, even though one could build it using earlier versions of Visual Studio and .NET. I'm using a popular XUnit package for creating the unit tests, even though some other packages like, for example, NUnit should also be fine. The purpose of the sample is to demonstrate the full TDD development cycle. Aside from adding the created test to the automated test collections, because this is a task more for the release management than for the developer himself. Now let us switch over to the Visual Studio. Currently we have an empty solution with just a skeleton of projects. We assume that we are doing our new development within our main project. Our reusable project containing reusable functionality is NP Utilities right here, and our test project is np.utility.tests. Take a look at the packages that we are using. We have XUnit package. XUnit is one of the best unit test frameworks. The other two packages, Microsoft.NET.test.sdk and XUnit.runner.visual studio, are needed in order for us to be able to debug our tests within the Visual Studio. Not only to run them, but to debug also. Take a look at the Manage NuGet packages page, and we have here among the installed packages the same three packages, XUnit and two packages to be able to debug our code. So at this point, everything is empty. We assume we are adding new code to program.cs file. Note that this is .NET 6. Because of that, we don't need to explicitly write program class, and we don't need to add main method to it. We just write within the empty file. Assume that suddenly we have a task to split a string. For example, we have a string equals hello world
we want to split the string into two parts. The part that goes before LL characters within the string and after. We have a separator string and we have the separator equals to LL, and we need to get the substrings before the first instance of LL and the other substring after the first instance of LL, and we can see that it's the first part is going to be start string part should be equal to HE, the first two characters before LL, and the end string part should be equal to O world. Let's create our functionality in the most straightforward manner. And by the way, one condition that I want to add, we are not going to be using split method defined in the string. We assume that we don't have this method available for us, but we are going to be will be using some other methods, including index of and substring, which are simpler methods than split. So basically we are creating a special implementation of the split functionality. First of all, we want to get the index of our separator within our string. So int separator idx equals str index of ll. Index of separator. Secondly, the first string of the split will be the substring of our string from 0 index to our separator index. So we can write string start str part equals string substring of from 0 to separator index. Now we want to find the index of the beginning of the second part. To find the index of the second part, we sum up the separator index and the length of the separator. So part begin idx equals separator idx plus separator dot length. Of course, the second part starts right after the separator ends, and it ends with the end of the string. So we can do string end str part equals str substring of end part begin idx, and automatically it's going to go to the length of the string. Now we want to test whether we got the correct split or not. So we're going to print out our start string part and end string part to the console. So we have console right line, and now we're going to do start str part equals start str part, and the same we're going to do for end str part. And the str part, and now we're going to run it while it's printed. So as you see, the start str part indeed equals HE, just as we thought it should, and the end str part indeed equals to O world with an exclamation mark at the end, as we thought it should. So everything looks good. Now we might want to be able to reuse this code for some other similar cases, but with different strings. So in the beginning, we are creating a method as close to the place where it's going to be used as possible. So we create a method that returns a tuple, string, start, str part, and string and str part, and we call this method break string into two parts, and we pass to it string str and string separator. And now we place this implementation. We just move it from here to here, and of course it's still not legitimate method because we don't return anything. But as soon as we return the tuple start str part and str part, it's going to go green. Now we are fine. The method should work fine, except that now we need to redefine our start str part and then str part in the main program. So we're going to create string start str part and str part equals break of strings and separator, and now we're fine. And now let's run it again and make sure, okay, that we are still getting the same answers. Start part should be at HE and end part should be O world. Here we are. It returned everything fine. We assume our method is pretty close to correct. Now we are going a bit further. In order for this method to be available not only in this project, we are going to turn it into an extension method within the static class string utils within NP utilities reusable project. So we simply copy this method, place it here, and make it public static as an extension method, and put this in front of our string argument definition. So now everything is good here. Now we're going to be using the same method. Here all we need to do is to put the string in front, put the method name after period as an extension method, and then the using for NP utilities. So now let's try to run it again and make sure that everything works the same. We got exactly the same. Start part is HE and end part is O world. Now we are going to have even more fun by adding our test file. We assume that this file is going to contain all the tests for our string utils static class. So we call this file test string utils. We make it public. We remove usings that we are not using. We make the class static because all the methods within string utils are static and they don't need any state to test them. And we start writing our first test for our method break string into two parts. And we call this method public static void. We call this method bring string into two parts test. And so far this method is not going to be taking any arguments. And since we are using XUnit, we are going to mark this method as a test as a fact. And of course, we need to control period use XUnit in order for our fact attribute to be resolved. And then we simply copy the stuff that we have here into our unit test, because we need the reference to NP utilities project. And here at the very end, instead of writing out the results to console, and indeed we should remove it here because in several days everybody will forget what this writings to console mean, we are going to create two variables, string expected start str part, and it's going to be our HE, and string expected end str part, and it's going to be O world. And after we call the method that we test, we are going to verify by using assert functionality, which is part of the library and part of any unit test library. We are going to verify that obtained start string part and end string part variables are indeed equal to the expected parts. Assert equal expected start string part, start str part, and of course we need to do the same with the end parts. And now we are going to open this go to test menu, open test explorer. We're going to rerun the test just to refresh them. Okay, so we rerun this test. This is our test, and you can see it has a green color. That means that the test ran successfully. All the asserts passed. Now, in order to see what's going to be if the test fails, we can change HE to HE1, which is not what the break string into two parts method returns. And let's now rerun it. We right click on the method and choose run, and you can see that the method is colored red and the unit test failed. So now let's turn it back and rerun it, and lo and behold, it's going to be back to green. Yes, and now we're going to show how to debug the test. Again, the debugging wouldn't work without these two extra packages added to our tests project. So if we place a debug breakpoint right here, we can right click on the test and choose debug instead of run. And lo and behold, we're going to stop at the debugging breakpoint. Now we can use step over to get all the way to our method. We can step into the method by using step into icon or F11. Now we are inside our string utils break string into two parts method. We can check our variables. The separate is our LL. The start part index is 2. The start part is is HE, end part index is 4, and end part string is O world. And here we are going back to our test file. Both asserts are passing. Okay, this is all very good. We created one test and the test is working. Now we want to be able to test more combination of strings and separators to make sure that our generic function break string into two parts is working indeed, not only for this combination of hello world, string and separator LL, but for any possible combinations of string and separators, or at least for most common of them. Instead of the fact attribute, we have to use a theory attribute. Theory and XUnit allows us to use inline data attribute with different combinations of input parameters. But before we go to inline data, we want to create arguments to the test. All these 4 predefined strings will become arguments. So string str str. And by the way, let's write them vertically so that we could see them all at the same time. And then we're going to have a string separator. And just for fun, we are going to allow the separator to be null. And it's going to be string expected start str part and string expected end str part. And now we're going to remove all of this. They're going to be coming from the arguments. And by the way, the strings, we assume that the expected start str part and expected end str part can be null also. And now we're going to create our first test inline data, and it's going to be exactly the same data as we passed before. So the string is going to be hello world with an exclamation mark. The separator is going to be LL, and then the expected start part is going to be HE, and expected end part is going to be O world. And now let's make sure that it's working. First of all, we're going to rerun the tests so that they would get updated. It got updated, and at the same time it ran the test with our parameters, and the test was green. The test passed. So the parameters were exactly as before. String equals to hello world, separator LL, expected start part is HE, and expected end part is O world. So this is great, but what if we decide to use a separator from the beginning of the main string? For example, let's pass a different inline data with a different separator and correspondingly different expected values. So what if we do separator equals to HE or HEL, which is the same as the beginning of the string. So it would be logical if the first part before the separator is going to be empty, and the second will contain everything after the separator. And again, let's rerun the tests. And now it refreshed the test, and we can see the second test. We can rerun it now, where the separator is HEL. Let's run it, and it seems like it worked. The test is green. The only problem is that the inline data here and the two tests here are in different order. The test with inline data with separator HEL is actually the second within the theory, while here the test with the separator HEL is first. This comes because HEL is alphanumerically preceding LL. The inline data order doesn't stay. In order to force the test to be in the same order as the inline data, I usually introduced an unused argument, say double test order, and assign the test order according to the order of the inline data. So we're going to have the first inline data with separator LL as the first test and the second as the second test, and the order is underscored because it's not used within the implementation of the test, and it doesn't have to be used. But now if we rerun the tests to refresh them, the order of the tests will be the same as the order of the corresponding inline data. The first test now has separator LL exactly as the first inline data, and the second has separator HEL exactly as the second inline data. So we are doing great. We're already essentially running two tests instead of one. Now let's run another test with and both, by the way, are working, even though we didn't necessarily think about it ahead of creating the functionality. So now let's test the situation when the separator is matching the end of the main string. For example, it's going to be D star, and of course the first string return should be hello world, and the second string should be empty. Let's rerun the tests. Okay, we need to update the test order to 3, and then it's going to be in order. Let's rerun it again. Okay, you see that the last test is the test with a separator D exclamation mark is now the last one. in the same order as the inline data. We can run it, and lo and behold, the test ran successfully. And now what we want to do, we want to test what's going to happen if we pass the separator null. This is an interesting test, and it's possible to happen. So here the separator, we change it to null, and what we expect to happen is that first the start part returned should be the whole string, and the end part should be empty. Now we are rerunning tests. And we need to make it, of course, test order change to 4. Let's rerun the tests again. We are going to get the last test at the end, and not run. Separator is null as expected, and now let's try to run it, and boom, we have a problem here. Now let's put a breakpoint and step into the method for the last test. Okay, so let's step into our reusable method, break string into 2 parts. Okay, and let's move forward, and you can see that index of doesn't like the fact that the separator is null, so the separator null should be factored out as a special case. So, and for that type of separator, the separator index should be at the very end of the string, and of course the end part begin index should also be in the very end of the string, so that the first returned part will be the whole string and the end part will be empty. So we are going to create a special case. So first of all, make the special case to be the so-called main case, even though it's rarely needed. So we do string equals length. That will be the separator index, and then we do if separator is not null, then we do separator index equals string index of separator. Okay, I think we are beautiful, except that we also need to do the same thing with the end part begin index. So end part begin index also, let's make it null by default, but if separator is not null, we do end part begin index equals separator idx plus separator.length, which is good. So now let's try to rerun. This is, we kind of polished the function. We remove the bug from the method by treating the case when the separator is null as a special case. And let's now try to run our test that failed before, and lo and behold, test still failed. Why? Because it should be string equals length. End part begin index should be string, length of the whole string, so the second has nothing to do with the separator length. Now the test should run fine. Okay, beautiful. Test ran fine, and now we're going to come up with another test. And another test is non-null separator, but the one that doesn't exist within the main string. So we're going to have inline data hello world, and say string 1, 2, 3, 4 doesn't exist within the hello world string. And logically thinking, we need to get exactly the same result as what we got when the separator is null. The first part should be the whole string, and the second part, the end part, should be empty. First of all, let's rerun all the tests to get them refreshed. And now let's rerun the last test that has separator equal to 1, 2, 3, 4. Run it, and it failed. So let's try to debug it again. Let's put a breakpoint, do debug. We stopped at the breakpoint. Let's go to here. Okay, the separator is not null. Because of that, it will try to find the separator index by using index of, but the separator index will be -1. And correspondingly, the end part begin index will be nothing meaningful. It will be 3, yes. So start part will be substring between 0 and -1, which is nothing, or which is less than nothing in a sense. And because of that, this substring is going to fail. Yes, argument out of range except. So to fix it, we need to treat the separator index, the case when separator is not part of the main string, also the special case. So here we are going to do, say, int separator idx. Say we call it real separator idx equals. And now if real separator idx is not equals to -1, then and only then we are going to assign the separator index and end part begin index. But if it's -1, we will still, these two values assigned in the beginning will still remain valid. So now if separator is null or separator is -1, which means that separate index is -1, which means that the separator doesn't exist inside the main string. The returned first part is going to be the whole string, and the returned second part is going to be empty. So let's test it. Let's run it again, and we got it running. And now let's run all the tests to make sure that we didn't screw anything up with our blessed modifications. And you can see that all the tests are running fine. And finally, you know, what I want to test now, for example, is what if we have several separator that repeats several times within the string. Actually, nothing should change. It should only notice the first time when the separator shows up in the string, and then break the string according to the first location of the separator. So we see that the character L, you can see it 3 times. It's repeated 3 times in the string. We want to use it as a separator. Now it needs to show HE as the first part, return part, and low world as the second part. And of course, we need to increase the test order to 6. And let's rerun all the tests for them to get refreshed. And now let's run the new test with the separator L. Okay, it ran fine. And since we didn't modify the reusable method, we don't need to test everything else. We created 6 tests, thoroughly testing our function, and moreover, we modified this function, fixing a couple of bugs within this method while we were working on the test in order to make the tests run. Thank you very much for your attention.